Hi everyone, it's Mrs. Bebo. In this video, we're going to take a look at multiplying rational numbers. That's our main learning target for this video. How do I multiply rational numbers? The nice thing is that the rules for multiplying integers are the same for multiplying rational numbers, so there's no extra rules that we have to memorize when we work with these fractions and decimals. So in this expression, in this table, the first one, we have a positive rational number multiplied by a negative rational number. Well, a positive multiplied by a negative is going to give us a negative answer. For the second example, right, we have a negative multiplied by a positive rational number. So again, a negative multiplied by a positive is going to lead us to a negative product. Then for our next one here, we have a positive multiplied by a positive. Again, when you have the same sign, you are going to get a positive answer. And so for that last one in our table, you can see the same thing. We have a negative times a negative, so this is going to be a positive answer. So those same rules apply for rational numbers. Different signs, negative answer, same sign, positive answer. We just need to make sure we remember how to multiply with fractions and decimals. So with multiplying fractions, we cannot multiply with mixed numbers. Those have to be changed into improper fractions. Sometimes we can cross cancel to help us simplify the problem. And again, this only works when you multiply fractions and then you don't have to worry about a common denominator. So multiplying fractions, I know for a lot of my students, they feel it is easier than adding and subtracting because again, you're just going to basically multiply your numerators and then multiply your denominators and then simplify if possible. Now multiplying decimals, again, if you can long multiply, you can multiply decimals. Again, you're just going to forget about the decimal points and multiply like normal. And the number of decimal places that are in the problem are the number of decimal places that have to be in our answer. So taking a look at our first set of problems, all of these are going to involve fractions. So again, really good review, especially for cross-canceling, because all of these we will be able to do some cross-canceling on. Now for the first one, it says we're going to find negative 3/4 multiplied by negative 7/9. And again, we're going to write our answer in simplest form. So starting out, we can actually just ignore the negatives because this is going to end up being a positive answer. So this will be a positive answer. So if I write this out again, we're going to have 3/4 multiplied by 7/9. Again, we can do some cross-canceling between the 3 and the 9. So cross-canceling, essentially, you're just trying to find, are there any common factors between the numerator of one of the fractions and the denominator of the other fraction, so across from one another, right? And if so, if there are any common factors besides one, you can cancel that out, essentially divide by that common factor, and then you're essentially just simplifying the problem before the end. So a common factor between 3 and 9 is 3. So 3 divided by 3 will turn this into a 1. 9 divided by 3 will turn this into a 3. And now we're just going to multiply our numerators. 1 times 7, that's going to be 7. 4 times 3 is 12. And there's my final answer. Moving into the next example. Negative 7/8 multiplied by 4 and 4/14. Again, make sure we write our answer in simplest form. So with this question, I will point out that there are some options here. I have had students that are like, can I just simplify the 4/14 to start? Yes, you most certainly can. Reduce that to 2/7 and then go through and solve this problem. Again, just like we did on the previous one, right? You can cross cancel, multiply your numerators, multiply your denominators, and you're done. I'll just leave it as is. We're still going to end up with the same result in the end, but I did want to point out, yeah, that 4/14, not simplified, and you can definitely simplify it from the start if you would like to. Now with this one, we do want to point out this one is going to be a negative answer because we have different signs. So that is something that we want to keep in mind when we go and write out our final solution. So for now, I'm just going to ignore the negative though that's in front of the 7/8 just so that it's not cluttering up my work here. We can do some cross-canceling in this one between the 7 and the 14. Those can both be divided by 7. So 7 divided by 7 turns into a 1. 14 divided by 7 turns that into a 2. And then we can also cross-cancel between the 8 and the 4 because 8 and 4 both have a common factor of 4. So 4 divided by 4 is going to be 1. 8 divided by 4 is going to turn this into a 2. And then we just need to multiply our numerators. So 1 times 1 is 1. And then multiplying our denominators, 2 times 2 is going to be 4. And then, again, we did say this is a negative answer, so we need to make sure we put our negative sign out front. So this is going to be negative 1/4. All right, and then for the last one on this slide, negative 2/5 multiplied by 3/10. Again, they are different signs. So this means our answer is going to be a negative. So something to keep in mind, especially if you're going to not necessarily write it as, that negative as we move through the question, which I don't blame you, but just make sure you go back and remember to add that on to your final answer, which is why I'm making those little notes to myself, right? Like, oh, it's a negative answer, positive answer, so I can make sure I go back and add the appropriate sign. So taking a look at this one, we have the 2/5 multiplied by 3/10. Again, that -2/5, it is a negative. I'm just not writing the negative in front just to save some space on my work page here. That way it doesn't clutter things up. So we got the 2 and the 10 that you can cross cancel between. 2 divided by 2 is going to turn this into a 1. 10 divided by 2 will turn this into a 5. There is no common factor between 3 and 5, so those are just going to stay the way they are. And so we'll multiply our numerators. 1 times 3 is 3. And then multiplying our denominators, 5 times 5 is 25. And then I just need to add my negative out front, and it's good to go. -3/25. All right, so now reminding ourselves, how do we work with mixed numbers? So it's going to be the same idea where, again, different signs, negative answer, same sign, positive answer. But when you have mixed numbers, we cannot multiply with mixed numbers. You do have to rewrite them as improper fractions first. So with this first one, this is going to be a negative answer because, again, they're different signs. So again, I'm just going to make that note to myself, and then I'll add the negative on at the end. Now, writing out this question away from the problem, we got 3 1/5 multiplied by the 1 and 1/14. Rewriting these into improper fractions. Remember, you're going to do 5 times 3 plus the 1. And so that's going to turn into 16/5 multiplied by, again, we'll do the same math for the other mixed number to turn it into an improper fraction. So 14 times 1, and then plus the 1 is going to be 15/14. Now, the really nice thing with this is that we can actually do some cross-canceling. So between the 5 and the 15, we can cross-cancel. So 5 and 15 can both be divided by 5. So 15 divided by 5 turns that into a 3. 5 divided by 5 turns this into a 1. And then we can actually divide by the 16 and 14 because those are both divisible by 2. So 16 divided by 2 is 8. 14 divided by 2 is 7. And now we're going to multiply our numerators. So 8 times 3 is going to be 24. 1 times 7 is going to be 7. And then we just need to rewrite this improper fraction into a mixed number. So 7 goes into 24 3 times, because that's going to be 21, and then there's 3 left over. And then again, it is a negative answer, so we're going to add our negative back out front. And there we go. So -3 3/7 is my final answer for the question on the left. And now for the one on the right, same idea. So we do need to rewrite these into improper fractions before we can actually multiply. Now for this one, we have a negative times a negative, so this will be a positive answer, so we can just ignore those negative signs completely. And for the 1 and 1/6, again, following the same math on the previous example, you'll do 6 times 1 plus 1. So this will turn into 7/6 multiplied by, again, 7 times 2 plus 2. So that'll be 16/7. And then, again, really nice, we can do some cross-canceling. So cross-canceling between the 7s, those will both turn into a 1 because, again, you're going to divide both of them by 7. The 6 and the 16 can both be divided by 2. So 6 divided by 2 will turn this into a 3, and then 16 divided by 2 will turn that into an 8. And now we're just going to multiply across our numerators and multiply across the denominators. This will turn into 8/3, and then 3 can go into 8 2 whole times because that's 6, and then 8 minus 6 tells me that there's 2 left over out of the 3. So 2 2/3 is my final answer for the question on the right. All right, now moving on to decimals. So with decimals, again, you're just going to ignore the decimal point and worry about it at the end. Just think of this as normal multiplication. And what I mean by that, for the one on the left, it says find 67 thousandths multiplied by -1 and 42 hundredths. So we're just going to think of this as the question, 142 multiplied by 67, and then we'll go from there. So 2 times 7 is going to be 14. 4 times 7 is 28, plus the 1 is 29. 1 times 7, and then plus the 2 is going to be 9. Add our 0. 6 times 2 is 12, and we have a 1 already up there. 6 times 4 is 24, plus the 1 is 25. And so again, we carry a 2. 6 times 1 plus the 2 is going to be 8. And then we're going to add those two lines together. So again, just normal long multiplication, right? And so we end up with 9,514, which is definitely not our final answer. That would not make sense for those two decimals that we're multiplying together. And so we have to add in our decimal points. We also need to make sure that we're double checking the sign. I forgot to write that out at first. In this case, since we have two different signs, it is going to be a negative answer. And then if I take a look at my problem, I have 1, 2, 3, 4, 5 decimal places in the problem, which means my answer needs to have 5 decimal places. So we're going to add a 0 out front and then have our decimal point there. And so rewriting this a little bit more clearly, we'll have negative, and then it'll be 0, 9, 5, 1, 4 after our decimal point. And then that's it for that question. So same idea with the one on the right. We have a negative multiplied by a negative, so I'll be better this time and actually pay attention to what our sign should be. So this one is going to end up being a positive because you have the same sign. So same sign, positive answer. So we can actually just ignore those negative signs. And then just like the previous question, we're just going to multiply 4,893 multiplied by 8. That's how we're going to think through this question. So 3 times 8, 24, 9 times 8 is 72, plus the 2 is 74, 8 times 8 is 64, plus the 7 is going to make 71, and then 4 times 8 is 32, plus that 7 is going to be 39. And again, my answer is not 39,144. That would not make sense for this question. We have to go back and actually double check how many decimal points are in, or how many decimal places, excuse me, are in my problem. And we have 4 total, which means I need 4 total in my answer. And so the final answer for this one, again, if I write it off to the side just so it's more clear, is going to be 3 point and then 9144. And there we go for those examples. All right, so now we're going to take a look at some questions where we have, again, that mixed form. Unfortunately for both of these, you do have to use fractions. I know for my students, they're like, no, I want to be able to use decimals. But the 1/3 and the 2/3 makes it so that these questions, you have to use fractions. The nice thing, though, is that those decimals that we're given, we should know their common fraction forms. So starting with the one on the left, we get find 1/3 multiplied by -2 and 75/100ths. So this is going to be rewritten as 1/3 multiplied by -2 and then 3/4. Now with this question, we have different signs. So this is going to be a negative answer. And again, we cannot multiply with a mixed number. You do have to change it into an improper fraction. So again, you multiply and then we add. So we're going to have 1/3 multiplied by, and again, we can just leave the negative on this one, 4 times 2, which is 8, plus the 3, which is going to be 11. And so we got 11 over 4. Now this question, we actually can't do any cross canceling. So we're just going to multiply across our numerators, multiply across the denominators. So 1 times this 11 is going to be 11. The 3 times 4 is 12. And again, this is a negative answer. So negative 11/12 is my final answer for this one on the left. Same idea with this question on the right-hand side. So we have the 2/3 multiplied by a -4 and 25/100ths. This is going to be, again, a negative answer because we have different signs. So that's something to keep in mind. And then we'll have basically 2/3 multiplied by -4 and 1/4. Again, we do need to rewrite that mixed number into an improper fraction. So this will be 2/3 multiplied by, this will be -17/4. And with this one, we can do some cross canceling between the 2 and the 4. So 2 divided by 2 turns this into a 1. 4 divided by 2 turns this into a 2. We'll have a 1 times -17, so -17 over 6. And then we just have to say, all right, how many times can 6 go into 17? That is going to be 2 whole times because that's going to be 12. And then 17 minus that 12 gives me a remainder of 5. So -2 and 5/6 is my final answer for this one on the right-hand side. All right, so that's going to conclude this video. Make sure you check out part 2 where we will evaluate algebraic expressions that involve multiplying with rational numbers as well as a few story problems. Thanks for watching.